11 in exercise 4.3. This one links closer to your homework set. Okay, it says that the highest power of x in a particular polynomial, okay, fx is actually 2x cubed. And the root of the equation fx is equals to 0, of the equation fx equals to 0 is actually negative 1. So negative 1 is actually a root. Okay. And then also given that x squared minus 4x plus 2 is a quadratic factor of fx, we want to find the expression for fx. First we need to observe about x squared minus 4x plus 2. Okay? X squared minus 4x plus 2 is a factor that cannot be factorized. No matter how many times you try to do the cross method, it will never ever be able to factorize. Okay? And then after that, with this statement saying that negative 1 is the root of this equation, that will mean that x plus 1 is a linear factor. Right? So we are able to get these two pieces of information from the last two sentences of the question. Okay? And x squared minus 4x plus 2 is actually a factor. That means that fx is going to be made up of x plus 1, which is a factor, and x squared minus 4x plus 2, which is a factor. There is no remainder because they are factors. Okay? But is that all fx is going to be? Fx can't just be this, because there's another piece of information that we have not used yet, which is about this 2x cubed. Okay, if we were to expand this thing here, we will find that x times x squared is the only way that I will get my x cubed term. Okay, and x times x squared is not going to be 2x cubed. Okay, so how do we introduce the 2x cubed into this question? It can only happen if 2 appears over here. Okay, so that I can have my 2 times x squared. Right? And that will be the answer. Okay? The question simply wants you to form the expression. Actually, there's no need for any explanation in it. It is about just forming this up. Okay? You understand what I'm saying? Any questions? Yeah. Do we need to expand? No need. Okay, this is also an expression, okay, that represents fx. You can expand, but there's no need for us to do it. Okay, wait, but the question, the question also asks to put in descending powers of x, right? Sorry, I didn't see the power. Because the question says must be in descending powers of x. Then we will need to actually expand this. Powers of x, that means that the powers of x itself must be in decreasing order. wants us to find the number of real roots for fx equals to 0. Okay, so if fx equals to 0, that means this expanded form is equals to 0. But why would we want to use the expanded form when we already have the factorized form? That makes things slightly easier for us to look at it to discuss. Because when we have it written in the factorized form, I will be able to easily tell that x plus 1 is going to be equals to 0, or x squared minus 4x plus 2 is equals to 0. In our solving process. Because after all, even if I have an expanded form, I will still need to go through the long division, the factorization process in order to know what are the factors in order to reduce this. Okay, but since we already have it, we can skip through that process. Yes. So in this case, x plus 1 equals to 0, we see that x is equals to -1, we have a root over here already. But since the question is asking about how many roots are there, they're not asking for the exact value of the root. Okay, all we have to do is look for the discriminant for this one here. Okay, so the discriminant in this case happens to be 8, which is more than 0. And what this will tell us is that how many roots will there be for this quadratic equation? Alia, what do you think? How many roots will there be for this quadratic equation given that the discriminant is more than 0? There will be 2 real roots. Okay? So when discriminant is more than 0, there are 2 real roots to this equation. So because there are 2 real roots, okay, in the quadratic part, and the linear one will give us 1 root. So in this question, there will be how many real roots? I just continue here. Okay, there are going to be 3 distinct real roots. For this equation. Okay. When fx is divided by x minus 3. Okay, so since we already know that fx is expressed as this, or you can choose the expanded form, is also fine. So what theorem will we use to find out the remainder? We'll use the remainder theorem, okay, and we choose x equals to 3. You will find that the remainder is negative 8. alright, we'll just finish up 4.3 already. Okay, so hopefully you will be able to do the homework already. Alright, let's look at 4.4 now. Fractions are fractions that has algebraic terms. Yes. Easy or not depends up to you. Okay. Okay. So for algebraic fraction, right? Okay, generally we will have it such that on the top and at the bottom it is an algebraic term, so we can express it as fx and gx. Okay, so it's a polynomial. Okay, so the generic form. Okay, it can be a cubic polynomial, a quadratic polynomial, linear polynomial, okay, or just a number is also considered algebraic fraction. Okay, so long as they are not both numbers, right, then it will be algebraic fraction. But of course, if I write it in such a manner that for fractions, okay, the denominator cannot actually be 0. And whenever we discuss about fractions, we always discuss about proper and improper fractions as well. Okay, so there is a way for us to define about proper fractions in algebraic fraction versus improper. Okay, so earlier in this chapter itself, we talked about the degree of a certain polynomial. So, Yan, what does degree of a polynomial means? Sorry? Yes, very good. Okay. It is the highest power of x. So when it comes to a proper fraction, me choosing to ignore the conversations going on in the classroom doesn't mean they're not aware. Okay. So proper fractions, alright, will mean that in a number sense, okay, we will know that things like 2 over 5, 3 over 7, they are considered proper fractions, right? So how do we translate this idea into algebraic form? Okay, that will be when, if I have fx and gx, okay, degree of the fx will have to be lesser than degree of gx. Okay, where the top is always smaller than the bottom. Okay, and in this case, how do we compare this idea of smaller or bigger? We look at the degree of the polynomial. Right? And in the case of improper fractions, okay, we see that things such as maybe 10 over 2 is an improper fraction. Okay, or 12 over 7 is an improper fraction. Okay, before we move into the formal definition for algebra, I'd like to ask you, do you think that the number 5 is it considered improper fraction? Does it fall under the category of proper or improper? How many of you think that 5 is considered a proper fraction? Who thinks that 5 is considered improper fraction? Why do you think that way?
Because 5 over 1 is improper.
Very good. Okay, because 5 over 1, okay, is the explanation. Okay, so with this logic, we will be able to tell that improper will mean that the degree of fx must be bigger or equals to the degree of gx. So if at the top is a cubic polynomial and at the bottom is also a cubic polynomial, okay, then we will be looking at improper fractions. That's the reason why we need to define this, because it will affect the process of us doing partial fractions. I'll erase this WA2 topics because I think we're still going through some finalization in the department. Right, so I'll let you know when there's confirmation. Okay, so what exactly is this partial fractions that we're talking about? Okay, so we have already previously learned that 1 over x plus 1 over x plus 2. Okay, if I want to combine things up, alright, I know that the denominator that we will have is x times x plus 2. And then we have 1 times x plus 2 here, plus 1 times x. That will allow us to simplify to achieve this. Okay, so in doing partial fractions, right, our concern is about how do we actually move from a fraction like that back to this. Okay, so that is the whole process that we're looking at when we do partial fractions. Okay, where we want to look at it in parts. Right? So there are certain rules that we have to follow, right, when we do our partial fractions. I'll just write it down on the whiteboard, you copy first, okay, before I explain. Could I explain? Ready? Right, let me explain what are all these steps over here in doing partial fractions. Okay, so whenever we have our partial fraction question, okay, for example in try 19, okay, they give you something like that. Okay, the very first thing that we must check is whether this fraction that we're given, is it a proper or improper fraction. Okay, so to deduce whether proper or improper, we compare the degree of the polynomials at the top and at the bottom. Okay, so that's the very first step we must do. Because if it is improper, we need to do long division. I will show an example later on. Okay, after we have done all the proper ones first. Right, step 2, we will have to also factorize the denominator of proper fraction completely. Because it is the denominator that is really important. Okay, as per the example that I showed earlier, right, from x and x plus 2, we combine it, okay, then we multiply. Right, remember the one that I showed. Okay, first step was to actually combine it together like that. Okay, so we have to determine what is the combination that we have in the denominator. Because the combination that we have in the denominator will affect, okay, the kind of form that we get, right, in the partial fractions itself. Right, so what are all these different forms? Okay, so the denominator being the main constant, we have 3 types, okay, that we need to discuss over here. The first one is if it is a distinct linear factors. Linear factors, we need to understand what are linear forms first. Linear forms is when the power of x is actually 1. So we have example 2x plus 1 and x minus 4. These are what we call linear factors. So what is actually going to come out, okay, of the fraction itself is that they will come out in this kind of form. Okay, so when we start off with a fraction where the bottom is like that, okay, it can be split up into 2 of these fractions, okay, whereby each one is 2x plus 1, the other one is x minus 4. Each factor takes 1 fraction. Okay, a and b are numbers that we need to go and find. Right? So how to find it? I'll talk about it in step 4. Okay, another type of denominator that we can have is when we have repeated linear factors. And the repeated linear factors that I have over here is this x minus 4 squared. Okay, x minus 4 squared is what I mean by repeated linear factors. Okay, because x minus 4 itself is a linear factor, but x minus 4 squared, okay, is actually x minus 4 times x minus 4. Okay. So that's why we have the idea about repeated. Okay, so when it is being repeated, right, what comes out of this x minus 4 bracket squared is 2 fractions. Okay, so it is no longer one fraction per factor. Okay, for a repeated linear factor, okay, we will have 2 fractions coming out of it. Right, so 2x plus 1 will still have 1 on its own. X minus 4 will have 1. X minus 4 squared will have another 1. Okay, taking note that at the top it is still a single number a, b, and c, which we are going to find. Okay, the last type of partial fraction that we have, okay, is whereby the denominator has an irreducible quadratic factor. Irreducible meaning to say that it can no longer be factorized. So x squared plus 5, there's no way for us to factorize anymore. Okay, but I want you to take note that things such as x squared minus 1, x squared minus 4, right, these are things that can still be factorized. And they factorize out to become x plus 1, x minus 1, and this is x plus 2, x minus 2. So for situations like that, okay, it will end up, okay, being a distinct linear factor problem rather than an irreducible quadratic factor problem. Okay, I will show you an example later on as well. So I just want you to emphasize on this idea of irreducible, meaning to say it can no longer be factorized. That's why, okay, over here I write that it must be factorized completely. Alright, so what comes out of x squared plus 5 is that, okay, we will get a single fraction as well, but the numerator, we are going to have a bx plus c. Okay, so it is going to be a longer expression, it is no longer going to be a single number. Right, so these are the 3 different types of denominators that we have in discussion. Okay, then after that, how do we go about finding out a, b, and c? Okay, the process of finding a, b, and c, we will make use of what we learned at the very first section of this chapter, which is to substitute suitable values, or otherwise we compare coefficients. Okay, so these are the ways that we will I'll be using it to solve the entire question. Alright, any questions? Okay, maybe not. Alright, let's look at try 19 first. Okay, so in try 19, we follow the steps. This is a proper fraction because at the top this is a degree 1, bottom this is a degree 2. Okay, you need not write down what is the degree of the polynomials, right? But you need to be able to recognize it. So because it is a proper fraction, second step is to factorize the denominator completely. So what we will be getting at the bottom is that we will have x plus 2 and x plus 1. And for this fraction itself, okay, by the rules that we have about partial fraction form, we will see that this is going to be equals to a over x plus 2 plus b over x plus 1. We will always use capital letters a and b. We do not use small letters. Okay, that is the convention that we will take. Right? I wrote it out in a form like that. Okay, so that is clearer for us to see. But in exam, please write it in the next line because one line should not have more than one other side. Okay, so once we have it in this manner already, if I erase this part so that there's a focus. Okay, these two things are exactly equal to one another. This makes this an identity. Okay, so what we understand about identity is that they are going to be equal throughout for any value of x that we're going to put in. Okay, so I can multiply across the entire equation by this thing at the denominator. So if I were to multiply the left side by x plus 2 and x plus 1, okay, I'm going to end up cancelling it. But I cannot cancel on the left without doing the same on the right, right? So on the right, it is the entire fraction, entire two parts over here that I will have to multiply by this. Okay, and that will mean that it is this single one I multiply by x plus 2, x plus 1. And over here, this other fraction, I multiply by x plus 2, x plus 1. Okay, so each of it, I multiply by this denominator. And what happens is that the x plus 2 can cancel out. Okay, and this, I can cancel x plus 1. So in the next line of my working, I will be having 3x plus 5 equals to a bracket x plus 1 plus b bracket x plus 2. Okay, so we get rid of the idea of fractions because fractions is difficult to actually manipulate. Right? So over here, at this step, our focus now is to actually find out what is the value of a, b, and c. Okay, so that is where the substitution of suitable values is important or the comparing of coefficients is important. Okay, so what do you think you would choose to do, right, in a question like that? How will you go about finding a? Before, what do you think? X equals to negative 1. So x equals negative 1 helps you to find a. Submit x equals to negative 1. That will help us in finding a. Okay, yes, x equals to negative 2 will help us find a. Reason because it will cause this to be 0, b times 0 becomes 0. So that is what we will do in finding a. We did not find the things in sequence. It doesn't have to be a, b, c going like that. Sometimes you need to find c first in order to find other things. Okay, so in this case, with the x equals to negative 2, on the left hand side we will see this. And on the right hand side we will be left with this. You may press into your calculator for faster computation rather than showing all the substitution, especially if this is longer. So we will get negative 1 over here and negative a. So a is equals to 1. Okay. Then after that, in order to find out what is the value of b, we will find instead that x equals to negative 1. 1 plus 2 is equals to 1 over x plus 2 plus 2 over x plus 1. Okay, and that's how we get the partial fractions. Alright, any questions? Are you okay? If you're fine with this, alright, I just want you to go and practice a bit. Okay, I want you to practice exercise 4.4 question 1. I just want you to do question 1A. Okay, it's on your textbook page 89. Let's do 1A. Okay, so same thing, do partial fractions for 1A. Okay, I give you about 5 minutes, right? response. Shall we move on?
Oh yes.
Okay, let's look at, I want to look at part C, part D as well. Okay, what if I have x plus 10 over x squared minus 4? I just want to briefly talk about it. I will not go into solving it. Okay, so like I mentioned earlier, x squared minus 4, okay, although it is a quadratic expression itself at the denominator, we must recognize that x squared minus 4 can be factorized, okay, using the identities that we have learned in Sec 2, okay, which is x plus 2, x minus 2. Alright? Because this will affect the choice that we're going to make, right, in terms of the partial fraction form. Okay? So the partial fraction form that we will choose is a over x plus 2 plus b over x minus 2. Okay, take note that we always choose a plus over here also. Right? Then after that, the same steps will apply where we have the identity being formed in this manner. Okay? So then after that, I just substitute in suitable values. Okay, if you want to do comparing coefficients, that's also fine. Right, but I find that doing for this case using suitable values will be easier. Then after that, you will be able to solve it and get the answer to be negative 2 over x plus 2 plus 3 over x minus 2. Alright, so I'll leave it to you in your own practice. Okay. Let me now show you another example that requires repeated linear factors instead. Okay. Linear factors, alright, whereby x minus 2 squared is the one that is a repeated linear factor. Okay, so what this will tell us is that we will be getting three fractions. First one is a over x plus 3 due to this factor. The other one is b over x minus 2. And the last one is c over bracket x minus 2 squared. I want to emphasize that for repeated linear factor, the second one will have a square in it. Right? Then likewise, we multiply across the entire identity over here by this big denominator. Eventually, I will be having this. Okay? I hope that you are able to realize that whenever I multiply across, I am actually going to have a times whatever that's going to be left. Okay? Whatever that didn't exist in the denominator. So this one only had an x minus 2, a single one. So that's why we have x plus 3 as well as a single x minus 2. Okay? Now, how do we find a, b, and c then? Charmaine, what do you think? You can choose anything. A, you want to find A first, B first, or C first. Okay, so Charmaine decided to find C first. How would you find C? Then x equals to negative 3. If x is negative 3, then C will get cancelled already, right? So are you trying to find C first? If you choose x equals to negative 3, what exactly are you going to find first actually? A and B, will we be able to find B? Why not? Because of the x plus 3, yeah. Okay, so let's go with what you wanted. X equals to negative 3. Key into calculator for the substitution. We would get 50. Okay, now what will you think? What will you do next? After finding A equals to 2. X equals to what do you say? 2. Is it? Okay. So letting x equals to 2 helps you to find A, B or C. Helps you to find B. You let x equals to 2 like C, right? Okay. So let x equals to 2, we will be able to find C. That would be -5 on the left. Such that C becomes -1. So our last thing left is to find out what is B. So what will you do to find B? Joanne, what will you do? To find B. Yeah, how to find B? Here. You have many methods. You can substitute suitable values, you can compare coefficient. If you want to substitute suitable value, what will you choose? Why will you choose 1? You can choose other numbers, or you must sit in 1. Is there a reason for your choice of 1? I'm not saying that it's wrong. I never say it's correct. But is there a reason for you to choose 1? Okay, so you can put 1, in fact you can put any number, right? So 1 is just your preferred choice. Okay, yes. So you can choose 1, okay? So when you choose 1, you get more calculations, okay, that you need to do over here. Actually for me, I would have chosen 0. Okay? Why? Because I will know that this becomes 0, I will get -13. Right? So then after that, over here I'll know that it's just 3 and -2. So I'll get very fast calculations out of it. Okay, I can think quicker as well, rather than having to rely on my calculator. Okay, but up to your choice. Okay, if I want to choose x equals to 1, right? You just need to do some calculations carefully. Okay, and 5 minus 6 is -1, -14 equals to 4 times -1, -14. Is it correct? Okay, wait, -1. Yeah, calculate already. 1 square, 5 minus 6. B, 1, 2, 3, 4, 1 minus 2. Is that right? Oh, sorry. How am I doing here? I forgot the A and C, right? Equals to 2, 1 minus 2 square plus B, 4, -1 plus C is -1, 1 plus 3. Then I need to count every single thing, alright, when I substitute x equals to 1. Okay, and go and do your calculation. Right, I'll skip those steps. B is going to be equals to 3. Okay, I leave the manipulation to yourself. Alright, B being equals to 3, then you will get our final answer. Okay, so always remember to write your final answer, because finding out what is A, B, and C is not sufficient. That's not what the question wants. 1. So that's why I can actually change this to become a negative. Okay. I'll give this question a try. I want you to think x squared. What does x squared mean?